So in the Lewis model, we represent valence electrons as dots. The valence electrons are the ones that are most important in chemical bonding. They are the ones on the outside of the atom. They are most loosely held. So those are the ones that get involved in bonding. In the Lewis model, we have the Lewis symbol, or a Lewis electron dot structures. The valence electrons are shown as dots around the element symbol. So if we look at the Lewis symbol for oxygen, we're going to draw the element symbol. That's what it's called. Just O for oxygen. How many valence electrons does oxygen have? 6. We can tell because it's in group 6. So it's got 6 valence electrons. And so we're going to put 6 dots around it. So we've got, make those a little bigger. 1, 2, 3, 4, 5, 6. That's the Lewis symbol for oxygen. Any questions? Yes?
Why did you put one on the top and bottom instead of 3?
That's an excellent question. Why did I arrange them that way? There's actually several different correct ways. We put them top and bottom, right and left. So there's 4 positions that you can put them. And they'll go in alone first, and then they'll pair up. Now I could have paired up those 2, or I could have these 2 paired up. There might be some others that I'm just not thinking of. So exactly where you put the dots doesn't matter, but you put them on the top, the bottom, the right, and the left, so there's 4 positions, and you could have 1 electron or 2 electrons in each of those positions. It's a little bit like the dots on a dice, right? They have a different name, but I'm calling them dots, the spots on dice, right? They're always in the same configuration, and the advantage of that is we don't have to count them, right? So if you see a die and it's got dots like that, you just know that it's 5, right? You don't have to count them. And so one of the reasons that we put them top, bottom, right, and left is to limit the amount of counting that needs to be done. Because if you put them in a circle, so if I put these 1, 2, 3, 4, 5, 6, if I spread them out evenly around, then your eye has a hard time figuring out how many there are. You tend to forget where you started counting, and things get tedious. It also represents how the electrons are paired up in the orbitals. So this is not the best. Does that answer your question? Any other questions? And then here's the slide that explains it. So dots are placed a maximum of 2 per side, and this just gives us a simple way to visualize the valence electrons. So atoms that have 8 valence electrons are said to have an octet, right? Helium has a duet. It just has 2 electrons. The noble gases are the ones with octets of valence electrons, and they're particularly stable. Helium only has 2, but it is a noble gas, and it's also very stable. And so we have what we call the octet rule, that atoms tend to transfer or share electrons to achieve an octet of valence electrons. So essentially, the atoms are trying to look like noble gases. They can't change their nuclei, but they can mess around with the electrons so that they look like a noble gas. And 8 is the magic number.